1.2, day 1. So our learning goals, I can define congruent segments and use their definition to solve for unknown lengths with justification. I can determine which segments are congruent based on the markings on a diagram. I can write the segment addition postulate and use it to solve for unknown measures with justification. So first, we need to talk about measuring segments. So the distance between 2 points A and B can be written as the length from A to B, or AB. So we just have our 2 points with no line on top. So the length from A to B. AB with no symbols means length. And then we have AB is equal to the absolute value of x1 minus x2. So that's the difference of the coordinates. So if we look at these two coordinates, we have the difference would be from -1 to 3. Well, if we look at the absolute value, that's actually just 4. So the length of AB is 4. Absolute value means positive. So we want the positive length. Finding distance on a number line. So first we have AB. So we want to find from A to B. So even though these are negative numbers, okay, our length is still 1. BC. So from B to C, that length is 2. Then we have from FB. So from F to B, F to B. So that's from 5 to -6. So that would be 11. Remember, we want positive values. So from -6 to 5, we're increasing 11. And then CD. So from C to D, that is, again, 2. So what do you notice about BC and CD? Well, what do you notice? Hopefully you're thinking to yourself, well, that's the same length. So even though they're on different spots on the number line, they have the same length. So we have two, so congruent segments, that's 2 segments with the same measure or same length. It's marked with a tick mark or congruent mark. So in this picture, we have AB and CD. Those are both 4. So if you mark them with a little tick mark, then we know that they're the same measure. Congruent has a different symbol. So the congruent symbol is an equal sign with like a little squiggly on top. So that's a congruent symbol. Equal lengths means we have congruent segments, or vice versa. If you have congruent segments, that means you have equal lengths. So we know that AB is 4, CD is 4, therefore AB is congruent to CD. And then notation, so for equal lengths, we know that AB equals CD. Then we have congruent segments. AB is congruent to CD. Okay, determining which segments are congruent from a diagram. So, looking at this diagram, we need to look for matching tick marks. So, let's look for all the segments that have 1 tick mark. So, 1 tick mark, we have PE, PG, GA, and AT. Those all have 1 tick mark. So we have PG is congruent to AG, and that's congruent to PE, and that's congruent to AT. So all of those segments are congruent. Next, let's look for ones that have 2 tick marks. So 2 tick marks would be EN and TN. And finally, we would have segments that have 3 tick marks. So PO is congruent to OA, so those segments are congruent. Okay, flip the page. Using the congruent segments to solve. So use the diagram or give information to find PT. So PT is 5x plus 3. So on these problems, first thing you're going to do is you're going to label them. So PT is 5x plus 3. TQ is 7x minus 9. So what we know is that we have congruent segments from these marks. So congruent segments means equal lengths. So we know that these 2 segments lengths are equal to each other. So 5x plus 3 is equal to 7x minus 9. And now we're just going to solve. So we're going to subtract 5x from both sides. And then just to save time in the video, I'm going to do 2 steps at once. I'm going to add 9 to both sides. So we get 12 is equal to 2x. Divide by 2. And we get x is equal to 6. And then we want to check. So let's plug it in. So we know that 5 times 6 plus 3. So we get 30 plus 3, that's 33. That's for PT. And then TQ. We have 7 times 6 minus 9. 7 times 6 is 42, minus 9 is 33, and they are equal, so it checks. Next one. Again, first thing I want you to do is label your diagram. So PT is x plus 2. PQ is 10x minus 12, and that's the whole thing. Again, we know we have 2 congruent segments. So that means that PT and TQ are the same. So this is also x plus 2. So that means we have 10x minus 12 is actually equal to 2x plus 4. Okay, do you guys see where I got that from? 2x plus 4 is just this x plus 2, x plus 2 combined. Okay, and now we're going to solve. So we're going to minus 2x from both sides. And then again, to save time, I'm going to do 2 steps at once. I'm going to add 12 to both sides. Okay, so we get 8x equals 16. I don't know what I was thinking. 20. And then divide by 8. X is equal to 2. Now we're going to check. So PT is 2 plus 2, so that's 4. PQ is 10 times 2 minus 12. 20 minus 12 is 8. So 4 plus 4 equals 8. Yes, it does. 4 plus 4 equals 8. That checks. Okay, how would you find length how would you find each length based off the given information? So what is the distance from G of C to DQ? Well, if you look at this picture, from G of C to the kegs is 1, 2, 3, 4, 5. This is 5 blocks. And then from the kegs to DQ is 1, 2, 3, 4 blocks. So, looking at this picture, total, what is the distance from G of C to DQ? 5 plus 4. Total distance would be 9 blocks. Okay, in this picture, if GH is 31 and HI is 10, then what is GI? Well, what we're going to do, we're going to take 31 plus 10, and that's going to get us our whole length. So 31 plus 10 is 41. Okay. Our next one, GH is 45 and GI is 67. And then we want to find HI. So what we're going to do is we're going to take the whole thing and we're going to minus the part we know. So 67 minus 45 gives us 22. So what did we just do in these two pictures? Well, what we did was we added segments together. So a couple things first before we get to our segment addition. A postulate is a statement also known as an axiom, which is accepted to be true without proof. A theorem is a little bit different, as a statement that can be deduced and proven true from definitions, postulates, and previously proved theorems. So, another thing we need to know is between. M is between points P and Q if and only if P, Q, and M are collinear. So, an example would be a picture. We know that P, Q, and M are all collinear. Then we know that M is between P and Q. A non-example would be, here's our P and Q, and then we have M up here. So technically it's between the 2 points, but it needs to be on the line. It needs to be collinear. Segment addition postulate. So what we just did up here in this picture is segment addition. So if A, B, and C are collinear points and B is between A and C, then we know that AB plus BC will get us AC. So AB plus BC is equal to AC. Notice how I didn't have the lines on top for segments? That means I'm just talking about the length of these segments, not the actual segment. Using the segment addition postulate, we're going to make a sketch and write the segment addition postulate for the points described. Then we're going to use the given information to find the unknown measures. So, A is between points N and P. So N, A, and P. NA is 4, AP is 5, and we want to find NP. So 4 plus 5 gives us 9. That's our segment addition postulate. N is between P and T. So here's our picture. P and T, and N is between it. So PN is 11, and PT is 24. Then we want to find NT. So 24 minus 11 gives us 13, so NT is 13. Justification. So what does it mean to justify? To justify, it means giving a reason or a series of reasons for the particular approach used to set up and solve a problem. When justifying, you may use the following as reasons. So different definitions, postulates, theorems, and laws. So here's an example of solving a problem and justifying. So we're going to be using the segment addition postulate. With justification. So we are given, so this is our given, GH is 7y plus 3, HI is 3y minus 5, and GY is 9y plus 7. So from our picture, we know that GH plus, let's spread this out a little bit, GH plus HI equals GI. And the reason, segment addition postulate. Next, we know that GH is 7y plus 3, HI is 3y minus 5, and GI is 9y plus 7. And all we did there was substitution. Now what we're doing is we're going to combine like terms. So 7y and 3y is 10y. 3 minus 5 is negative 2. So that was just simplifying. Now what we're going to do is we're going to minus 9y from both sides. So we get y minus 2 equals 7. That was the subtraction property of equality. What you do to one side, you have to do to the other. Then we're going to add 2 to both sides. We get y is equal to 9. That was the addition property of equality. So now we know that y equals 9. And is that reasonable? Well, this is where we plug it in. So we know that GH is 7 times 9 plus 3, so that's 66. HI is 3 times 9 minus 5, which is 22. And GI is 9 times 9 plus 7, which is 88. 66 plus 22 equals 88. So is it reasonable? Yes. Checks out. Okay, flip the page, do another problem. We're going to be solving using congruent segments. With justification. So we're going to use the information in figure below to find KL. So we're going to justify each step. So first thing I want you guys to do is label your figure. So KL is 3x minus 2. LM is 5x minus 10. So from our figure, we know that these two segments are congruent. So we know that KL is congruent to ML. And that is given to us from our picture, okay? So that's given from these symbols, okay? It's given from our congruent symbols. Next, we know that from the congruent segments, we know that KL is equal to ML. Those lengths are equal. So now we can plug in. 3x minus 2 is equal to 5x minus 10. So this is from congruent segments. And then we use substitution. Now what we're going to do is we're going to minus 3x and get all the x's on one side. This is our subtraction property. Of equality. We get negative 2 equals 2x minus 10. Then we're going to add 10 to both sides. That's our addition property of equality. So we get 2x equals 8. Now we're going to divide both sides by 2. That's our division property of equality. What you do to one side, you do to the other. Well, that's a crazy looking equal symbol. So we get that x is equal to 4. Okay, now it wants us to find KL. So KL is equal to 3 times 4 Oh no. This was a plus. So this is actually 12. And this would be 6. Okay. So 3 times 6 plus 2 is 20. And then, is it reasonable? Well, let's see if it matches the other side. So ML is 5 times 6 minus 10. 30 minus 10 is 20. So it checks. Is it reasonable? Yes. Okay, summary of 1.2. So look over the learning goals. What do you feel you know at this point in your learning? And what are you unsure of at this point of your learning? What type of questions do you have? So make sure you fill these two in and then see what you know and what you don't know.